First thing that I always talk about before we actually get to the chain rule is when do we need to use it, right? We haven't had to use it yet when we're doing derivatives, right? We have our three rules: power, product, quotient, all right? So these are the problems that you guys have seen so far. These are the types of problems you guys have seen so far, right? Pretty much just power rule for all of them, right? Just power rule, right? X squared, so it'd be 2x. Sine is negative, or sine is cosine, 3, and then you find derivative of x, and then derivative of tangent. We've done that, right? That's just one layer deep. Let me change those so that we wouldn't need the chain rule. So the first one. So look at the first one. What did I do to the first one? X squared minus 1. What did I do to the first one? Square root over it, right? So now it makes it 2 layers deep. Why 2 layers? Because you have the square root of x minus 1, and then you have the original layer, which was x squared minus 1. So that's 2 layers deep. Okay? So look at sine of x, right? Sine of x, that's 1 layer deep. The derivative is cosine, right? So now look what I did over here. There's 2 layers. The outside layer, which is the whole thing. The outside, when I say the outside layer, I mean the whole thing. So the whole thing is sine of 5x. But now it's not just x, it's 5x. So that's that's another layer, just 5x. Okay? Same thing, kind of similar to number 1, 3x minus 2. I know they're not, this one's more of, matches the first one. Now there's a power of 7, right? So what's the outside? The whole thing. X squared minus 1 quantity to the 7th power. What's the inside? X squared minus 1. Okay? Same thing with tan x. The first one is just x, so that's okay. But now it's not tan x. Tan x squared is the outside layer. The inside layer is x squared. So each of those have 2 layers. Okay? So that's the first thing we're going to do. We're going to work on the layers. We're going to work on finding out the layers. So that's what pretty much this says. If you have to find derivative of what's called a composite function. Composite just means you have one function inside of another function, right? X squared minus 1 is inside the square root of x minus square root of x squared minus 1, right? 5x is inside the function of 5x, or sine of 5x, right? That's what I mean by that. So if we have 2 functions, one on the inside of another, first thing we do is find the derivative of the outside. Leave everything else the same. The inside stays the same. It's like when you're chewing into a, right? I know no one chews this way, but let's say you chewed so softly that it just broke the outside shell, right? You'd still have the chocolate and the peanut in there, right? Can I get to the chocolate without breaking the shell? No, I have to break the shell to get to the chocolate, right? Could I get to the peanut without breaking the shell and getting into the chocolate? No, right? You can't do that, right? So that's why we have to do the outside first and then work our way in. Once we do the outside shell, derivative of the outside shell, then derivative of the chocolate, then derivative of, the last thing is the derivative of the peanut. That's why it's called the chain rule, because you do outside derivative, then you chain on the next layer, then you chain on the next layer until you're done, okay? How do we connect them? With multiplication. That's why it's called the chain rule, because they chain together. It depends on how many layers there are, okay? Okay, so first thing. Let's find the outside, let's find the inside. Outside is always easy, because it's the whole thing. Outside is always easy, it's the whole thing, okay? So, I color code it at least to begin with, because it's easier for me to see. Okay, so the outside. Actually, it's not the whole thing. So the outside would be this. Let me color code this. The outside is cosine of something. Cosine of something. What is it cosine of? It used to be just x, but now there's a layer deep. Okay? What is the inside layer? 5x squared. Oops, not sine. Where did I put sine? Inside. 5x squared. If I were to put 5x in those parentheses, you'd have the original function. Okay? Let's look at B. First thing we always do, what do we always do when we're doing derivatives with roots? Anytime we have a root in a derivative, you guys did this yesterday on the quiz. What did you do first when you had a root in a derivative? Half power, yeah. Right? So this is not part of the chain rule. This is just part of what we've been doing. Okay, so let's have the outside. The outside is something to the 1/2 power. Isn't that the same thing as saying the square root of something? Right? Something to the 1/2 power. I can't get to the inside yet. Why don't I write 3x plus 1 there? Because that's the shell, right? I have to deal with the shell before I can get to the chocolate. Now that the shell is gone, now we can go to the inside, right? So the inside would be 3x plus 1. I can't get to 3x plus 1 without finding the derivative of the outside, right? The outside's the shell. This one's the chocolate, okay? Okay. Let's do the next one. So trig does this weird thing where if they want to square something, if they want to square either sine, cosine, tangent, cosecant, secant, or cotangent, they put the squared there. It doesn't really make sense to me. I don't really like it like that. If it makes sense to you, leave it there. But what this really means is this. Sine of x squared. That's really what it means. Okay? If you understand that, you don't have to rewrite it. But I always rewrite it because it messes with me. I don't like when they do that. Okay? My brain is thinking the right. My brain is thinking this over here. So I just say, might as well rewrite it. Do you have to rewrite it like that every time? No. If you can see it written like that, go for it. Okay? Okay, so it also helps me because when I'm finding derivatives of these things. So the outside, right? What would the outside be?
Squared.
Something squared. Something squared would be the outside. Why don't I say sine squared? Because you're not there yet, right? We're still at the shell. So I know it's something squared. Okay, now you ate through the shell. Now you're on the inside. Now what is the first inside layer? Sine x. Okay. This is, believe it or not, this is the hardest part about using the chain rule. If you can A, know when to use it, and B, tell the layers, the chain rule's easy. The next step when we actually do, on the next page, we're actually gonna find the derivative of these guys. And you're gonna be like, that's easy. Because it is. Because this is the hard part, breaking it down. Okay. Can we use one of our rules that we already know to do this problem? Yes, which rule can we use? Quotient rule, right? We can use the quotient rule, right? Yeah, so what I'm gonna do is instead of using quotient rule, remember when I said this a couple times. Anytime you can avoid using the quotient rule, do it, because the quotient rule turns into a big thing, right?
I do put up the x, like that's how I do it.
Yeah, so I think it's better to write it like that, right? Yeah. Why is that better? Because now you can use the chain rule. It's got an outside. The outside is something to the -1 power. So if it's something to the -1 power, you guys have done this before. Anything to the -1 power. How would we find the derivative of that? Let's say x. How would we find the derivative of that? Move the -1 to the front. And then what would we do to the old power? Subtract 1 whole. Right? You guys have done that before. That's what we're going to do on the next page. Just instead of being only x, it's 5x plus 1. When do we deal with the 5x plus 1? The next layer. The next layer, so the inside. Oh no. Is 5x plus 1. Okay. All right. Okay, so now example 2 is the same 4 problems, just actually finding the derivative, using the chain rule to find the derivative. So we already know what the outside and we already know what the insides are going to be. These are all 2 layers deep. So these are regular M&Ms, not peanut M&Ms, they're regular M&Ms, right? Okay. So let's look at this guy here. From the previous page, we know what was the outside and what was the inside, right? Mm-hmm. So for this guy, what did we say the outside was? Cosine of something, right? Cosine of something. Okay, so what's the derivative of cosine of something?
Minus sine of something.
Negative sine of something, right? So let's write that down. Negative sine of something. What do we put in there when we're finding derivative? Whatever was in there. Well, so what was in there at the beginning? 5x squared. So put that there. Chain. Chain means multiplication. So that was the outside. That's the derivative of the outside. I haven't touched the inside yet. I'm going to now. So now, let's do the derivative of the inside. What's the derivative of 5x squared? 10x. Only had 2 layers, right? So I'm done. There's a -1 in front, right? So multiply -10 times -1. So I would write it like this, but you don't have to. But if it's a multiple choice question, this is the way they're going to write it. Okay. All right, so let's look at number 2B, or 2B. This is a different one. Oh, that's E, sorry. 2B, here we go. We rewrote it first, right? We rewrote it. We said 3x plus 1, but instead of square root, we said 1/2 power, right? Okay, so let's do this. The outside, we said on the last page, was something to the 1/2 power, right? So go back to using the power rule. When we had something to the 1/2 power, what did we do? What did we do with the old power? Subtract 1 and then move it to the front, right? Yeah. So it would be -1/2, right? That's exactly how it's going to look over there. Exactly how it's going to look over there. We have 1/2 something to the -1/2, right? Chain. We have to rewrite the inside layer. So 3x plus 1. We haven't touched it, but we have to keep it in the parentheses. Now, let's find the derivative of the inside, which is just 3, right? Multiply now. Now we can multiply these guys because they're both monomials. 3 and 1/2, so we get 3 over 2. 3x plus 1, -1/2. We don't want to finish with negative exponents, right? So I'm going to write a fraction. I got a 3 on top, 2 on bottom. Since it's negative 1/2, it's going to move to the bottom with the 2. So square root 3x plus 1. Okay. Done. Okay. Let's go to sine squared. Again, I'm going to rewrite it because that's what I always do. If you don't need to rewrite it, I'm not going to make you. But the reason I rewrite it, I started rewriting it, is because doing the chain rule, it becomes a little more clear. Your outside is something to the second power, right? So if I had something x to the second power, a to the second power, whatever it was to the second power, right? Power rule said move the old power to the front, subtract a power. So it's just 1 now, right? Or you don't even have to write the 1. Rewrite what's inside. Then I had the inside layer. The derivative of the inside, derivative of sine is cosine. So you have 2 sine of x times cosine of x. Done. Do D. Do D right below it if you haven't already. So the outside is something to the negative 1 power. So that's negative 1 to the negative 2 power, right? Okay, rewrite the something. Derivative of the inside, 5x plus 1, 5. Couple things. First thing, multiply these two guys, and then the power needs to go down, right? This, not the power, but the whole thing. So you're going to have negative 5 over 5x plus 1 squared. Okay. All right. Okay, so the other side, I believe, is just 3 more problems. Same thing. Same thing we've been doing. Nothing new. There's only 2 layers, I believe, for each of these. Okay, so E, I'm going to rewrite it. 6x squared plus 1. This is 1/3 power, right? So outside layer is something to the 1/3 power. So let me find the derivative of that first. So we take the old power, move it to the front. Subtract a whole, which is negative 2/3. Rewrite the inside, which I haven't touched yet. Chain. Now let me find the derivative of the inside. Derivative of the inside is 12x. Just like we did on the last problem, we got to do a couple things. We got to multiply these guys here. 1/3 times 12 is 4x. So we're going to get 4x. And then since there's a negative exponent, that's got to move down. Okay, since there's a negative exponent, that guy has to move down. Oh, thanks. So we get x squared plus 1 to the 2/3 power. Okay. All right. Okay. F. Again, could you use quotient rule like we did, like we've been doing? Yeah, you could do quotient rule for this. If there's just a constant on top, 1, 3, -10, something without a variable, I always use this. I always do the chain rule. The only time I use the quotient rule is when I have an actual function on top. Okay, that's the only time I use the chain rule or the quotient rule. Since I don't, 1, let me just move it up to the top. So we're going to get 1, right, times 4 minus 5x, or 4 minus 5x minus x squared. And that's -1 power. You don't have to write the 1, but I'm just doing it because sometimes it won't be a 1, sometimes it'll be a 3, sometimes it'll be a -5, sometimes it'll be something like that, right? So just get used to seeing something right there. So what I'm going to do now is I'm going to find the derivative of the outside. The derivative of the outside is still this guy here. That 1 is just going to be multiplied. It's like if you have 1x to the -1 power, right? You just multiply what was already there and then subtract a power, right? It's the same thing. Okay? So you get, move -1 to the front, times what was already there, subtract a power. Rewrite the inside. We haven't touched it yet. Okay. Now the inside. The derivative of the inside is -5 minus 2x. It's a binomial, so I'm going to put it in parentheses. Okay. Now let's clean it up so it'll actually look like, if it's a multiple choice question, that answer won't be there. Okay. So let's clean it up to make it look like one of mine. So the first thing I'm going to do is I'm going to multiply these guys. So I get -1. This guy can stay up with -1. -5 minus 2x. The other guy has to move down because it has a negative power. 4 minus 5x minus x squared squared. You can distribute the negative if you want, the -1 on top, or you can leave it like that. Okay. So like I said, identifying when I have to use it, and then identifying the outside first, then the inside. So everything we've done so far has 2 layers. And I believe the last one on this page has only 2 layers as well. As we move on, you're going to have 3 layers. Yeah. 4 layers is, I don't want to say rare, but you won't see it a lot. Usually it's 2 or 3 layers. Usually these are 2 or 3 layer problems. Okay? Okay. G, how can I rewrite G so I can use any of my rules? What's the way I would rewrite this guy here? Could I use the quotient rule? Yeah, but there's only a 1 on top. So I don't want to have to use the quotient rule. I want to use the chain rule. So, but first I have to rewrite it. So I can go 3x plus 5. What power would it have to be? -1/2, yeah, -1/2. The 1 you can write in the front, it's a good habit to write that in the front because, like I said, it's not always going to be 1. So do you have to write that 1? No, but I'm doing it because it's the notes and it won't always be a 1. If it was a 3, it would be a 3. Okay, so here we go. We have the first layer is something to the -1/2 power. So the 1 was already there. I'm going to multiply by the old power, right, which is negative 1/2. Parentheses, subtract a whole from the power. 1 whole minus 1/2 is negative 3/2. Rewrite to the inside. Okay, chain. Inside, 3x plus 5. The derivative is just 3. Okay? So I got to multiply, multiply, multiply. So that's negative 1/2 times 1 times 3 is negative 3/2. So negative 3/2. And then the power has to move down because it's negative. So it's going to move down with the 2. Positive 3/2. Okay. All right. That's the basic idea of the chain rule. The only new thing is that the layers. There might be an extra layer or two that we haven't dealt with. It's fine. The first thing you always do is, how many layers is there going to be? Well, we do that at the beginning. I color code that. That's why I color code that. Okay, I always color code it when I'm doing these problems, either in my head or on paper, because I know that's part of the gig. Okay, all right. So now, these are layers deep. These are a couple layers deep. So these are going to be the 2 and 3 layer ones, or the 2 layers and 3 layers deep. We've only seen 1 layer deep. So the first thing I want to do is the first thing we did. How many layers does it have? Okay. Okay, so rewrite this a couple different ways. First of all, so it's sine of something cubed. Right? Sine of something cubed. That's what that 3 means. Okay. And then 4x plus 1 has a power. 1/2 power. Don't multiply the powers. Leave the powers alone. We're not doing any of that. We're just finding the outside and the inside and the inside. Okay? Okay, so here we go. How many layers does this one have? Take a guess. 3 layers. It does have 3 layers, right? This is a 3-layer problem. Okay, here's the hardest part. Hardest part is the first step. What's the outside? Something cubed. Yep, something cubed. Okay. Does it matter what's cubed? No. It's just something cubed. Okay, so let's go 1 layer in. Oops. What's the next layer? Actually, this one has 4 layers. I forgot. What? Actually, it's 4 layers. Okay, so what's the next layer? Sine. Sine's the next layer. Sine of something. Sine of something. What's the next layer? There you go, the 1/2 power. Something to the 1/2 power. Something to the 1/2 power. And then the last layer is what's left, 4x plus 1. Okay.
Like an amendment.
So when we do this on the next page, this page, I don't know where we're doing it, but we do it, we have to go in order. Okay. Okay, let's see B. Take a look at B. How many layers do you think B is going to have?
5.
No, not 5.
It doesn't 4.
I think it only has 3. I think it only has 3 because it doesn't have a square root here. It doesn't have a square root over x squared plus 1.
3.
Okay, so let's see. So you're going to have a 3. Move this guy to the top, right? Move tangent. I think it might have 4. So I haven't done any derivatives yet. I'm just rewriting it. So what power is tangent of 4x squared plus 1 going to have? Negative 1/2. Good. Yeah, I think it is 3. I think it is 3, yeah. Okay. Bless you. Outside. What is the outside layer?
3 times something to the negative.
There you go. 3 times something to the negative 1/2. The outside. Okay. Let's go inside a layer. What's the inside? First inside layer. Tangent of something. Good. Tan of something. And then the last inside layer would just be 4x squared plus 1. Okay. All right. Okay, so that one only had 3 layers. 4-layer ones, I don't want to, like I said, I don't want to say they're rare, but they don't show up often. Okay? Somewhere between not often and rare. Okay? Usually it's 2 and 3 layer. Most of the ones on tests and quizzes are 2 layers deep. Maybe the occasional 3. Okay, so now let's go to the same one, 3a, and let's actually find the derivative. Let's actually find, this one's got 4 layers, right? Okay, so let's rewrite this. Did we skip one?
No.
No?
2.
Good? Okay.
A and B. Yeah, you might be crazy. Where
Never mind. I am crazy.
Bro, you're rambling.
Okay. Here we go. What was the outside that we said it was? Earlier, what did we say was the outside? Something cubed. Good. Something cubed. Brackets cubed. Okay? So if we had something to the 3rd power, how would we use the power rule? We'd move the, what would we do if we had something cubed? Move the 3 to the front. And then what would we do? Subtract 1 from the power. That's what we're going to do. But this time when we're actually finding the derivative, we can't leave it all blank. So what do we put in? The inside. We haven't touched the inside yet, but we're going to in a second. Okay. Chain. Okay, what was the first inside layer? Sine. What's the derivative of sine? Cosine. Good. Cosine of something, right? Well, rewrite what it was. 4x plus 1, 1/2 power. Okay, halfway done. What was the next layer that we said? Something to the 1/2 power, right? Okay. So if I have something to the 1/2 power, it's just the power rule. Move 1/2 to the front, subtract a power.
Yeah, it becomes 2.
Rewrite what I have, what I've written, what I haven't yet. Anything on the inside, rewrite it. Chain. Last, fourth and final layer is 4x plus 1. The derivative is just 4. So I have this times this times this times 4. How can I simplify it? A couple ways. 2 ways that I'm saying. First of all, these guys are monomials. These are all coefficients. So I can multiply all of them. That's the first thing.
So just 6, I believe.
So it would be 6, yeah. Okay. The reason I'm drawing a fraction is because I see some negative exponents. Negative exponents means I need a denominator if I don't already have one. So 6 is going to go on top. So sine, so the first sign here, let me see, where is it? Nope, I don't want that, right here. So this guy here, the sine squared guy right here, this guy's going to stay on top. So I'm going to move that guy right here. This guy is just going to get its square root back because it needs a square root. Those are going to both be up top. This guy here has a negative exponent. It's going to move down, and it's going to have a square root because it's 1/2 power. Then I'll be done. Okay? Okay, so let me write that down. Brackets, sine. Actually, you know what? I probably should, on the inside, give it its square root back. You don't have to. You could leave it as 1/2 power, but since it started with a square root, I put it back most times. Then it would be cosine 4x plus 1. The 1/2 powers are taken care of by the square root. And then the 4x plus 1 needs to move back down to the bottom. Done.
Right, now plug in 2.
Okay. That's as hard as they'll get.
Man, I can't wait to actually start.
That is as hard as they'll get. Okay. I usually like to do that. I usually don't like to do one like that on the first day, but we're kind of going a little fast here, so it seems like you guys are kind of picking up on it, so we're okay. All right. Let's go 4A now. Or 4B, sorry, 4B.
This is the 3, yeah, this is the 3 one. Okay.
This is not answered. I guess we got like 6.
Okay. Rewrite. So it was 3 tan 4x squared plus 1, and then all of that was to the negative 1/2 power. That's what we had on the last page. So just rewrote it. I didn't change anything. I haven't done any derivatives. I just rewrote it. Okay, so using our color coding or our what we did on the layers, right? So what was the first layer for this guy? There you go. So 3 times something to the negative 1/2 power. So the power rule says take the old power and multiply it times what was in front already. And then subtract a whole power, negative 3 over 2. Rewrite what was already on the inside. Just rewrite it. Okay. That's the first layer. Second layer was the tangent.
Cosine. So What was?
Yes, so what was the derivative of, I believe, secant squared?
Negative secant. Cosecant.
I believe it was secant squared. Yeah, secant squared, okay.
Yeah, I don't want.
All right, so let's write that in. Chain. There we go. Okay. So now we're going to chain to the old one, to the first one that we did. So tangent of something means secant squared, right? So I'm going to write secant. I'm not going to write the squared there. What I'm going to do is I'm going to write it like this. Brackets, yeah. That means secant squared. I haven't got to 4x squared plus 1, so I'm going to write that back in here. Chain. Last layer was the 4x squared plus 1, which is just 8x. Same thing as the last one. The monomials multiply. So we get 8 times 3, which is 24, times negative 1/2 is negative 12.
Yeah.
I see that I have some negative exponents, so I'm going to have a fraction. That's why I'm writing a fraction. So negative 12x. This guy here has a positive exponent, squared, right? So it's just going to stay on top. This guy here does not have a negative exponent. Or it does have a negative exponent. It's going to go down here. And then I'll be done. Secant 4x squared plus 1 squared. Tangent 4x squared plus 1 positive 3 over 2 power. Done. Okay, so we got about 10 minutes. I don't want to go on to the next one yet because it's combining rules. It's not hard. It's just I don't want to get into that yet. What I want to do is you have on the last page, there's a bunch of extra space, right? So on the last page, there's a bunch of extra space. So I want to give you at least one problem to try on your own. Okay, at least one problem to try on your own. Okay, so here we go. Let's try this. Whoops.
This is 7C. What? Keep complaining. It's gonna get worse.
We don't have this. We don't have Desmos. Or that's math. That's math. That's math. Desmos is graph.
Omega math? You mean beta
What?
math? Delta math?
Think about that.
Technically, delta math implies the existence of alpha math.
Data.
There we go. Extra practice.
Exactly.
Charlie.
Extra practice. Here we go. Extra practice number 1. If we have time to do 2, we'll do 2. But for right now, I want to do this one. So here we go. F of x equals tangent squared of 5x. And then one more. Let's make it a good one. F of x equals 2 4th root 9 minus x squared.
4th root, that's crazy.
There you go.
2 to the 4th. Why did I say 2?
Okay, so we got about 2 minutes. So here is the work behind it. The answers were there, but the work behind it. So the first one had 3 layers. The second one only had 2 layers. Okay.
Yeah, I literally, this is the last one I did for the year.
We learned a different story.
Oh, we did it?
No.
Wait,
Okay,
so
so,
you want me, this page?
Yeah, so we'll finish the rest on Monday.
Yeah, you don't need this page, like, but since you already did this page, you already know what page.
Oh, so I did this page, like,